Hello, this is Dr. Shefali Sonone. We'll have an insight for the interesting topic Steganography. Actually, the Stigmography is the Greek word which mentions that some covered writing is there. So, whichever is the data or the information, if you want to hide, you can place it under some other data so that that particular data which may not get exposed to the particular viewer. So what exactly the idea is there, and I would like to continue with some of the points for the discussion, that what is the overview of the Steganography, what are the research efforts, because number of researchers are working over this and number of independent trials are there. So which trials are possibly successful and which are giving you some of the robust or rather fragile steganography, that is totally dependent on your application itself. We can find it out over the research efforts. Some of the visible and invisible steganographic attempts are there. What is the application point of view of those, we need to find it out. Some algorithms are divided into the public or the private category. So we need to have the combination of those with some cryptographic algorithms. Some spatial domain or transform domain trials are there, and the characteristics are important for the study purpose. And with the steganography, though the steganography is not aimed for the security concerns, but how the security is to be estimated, we need to find it out. So if any literature is to be studied, you may find some interesting stories for your ancient steganography. Steganography is not new. You may find out some of the incidences from the 2011 onwards, or wherever the steganography came in picture again. But some of the incidences you may find out that okay, there are certain slaves who are having some messages written down over their heads, and the hair is grown down, and then they are passed over the for the journey purpose, or some message written balls are swallowed down, or you may find out some invisible inks are there with which the messages are written. Or this particular example is there where you can find out some printed book of the cryptology, but that cryptology book is studied in such a way that whatever are the successive columns are there, and with those, if the words are read down by the person, then it will result into a legitimate prayer, and you may find out that how old it is. So there are so many interesting stories there, or you may go through this one. But in the literature, it is known that one of the name, that is the Steganography has given as one of the name which is known as the prisoner's problem. So what exactly is the prisoner's problem? It is the well-known story that there are two prisoners and they tried to make the escape plan by writing one cheat from one to other, and there was some hidden message in the particular cheat, but of course the warden is somewhat smarter than these two thieves, and she could catch the particular plan, and that's why it is called as the prisoner's problem. So whenever we talk about for the steganography, what exactly is the important, what aspects we need to concentrate is very important. That is, whatever is the message you want to go for, whether it goes for the complete hiding of the existence of the message, or it goes for finding out some of the characteristic of the human visual or the audio system, because majority of the times we are going for the audio signal or the video signal or the image signal which we are observing from our eye, that is the naked eye we need to consider, or the by default the ear system of the human being. So using only the subset of the letters or the words, it is said that we are just going for the text steganography in this particular concern. And if any longer message is there, that longer message is broken down and it is stored or it is hidden down into some other one, and for which we can say that it's an invisible ink. It is not exactly the invisible ink, but whatever is the written message is there, that is not viewable or that is not understandable by the human visual or the audio properties. Now, many of the algorithms are so popular with the literature, and those algorithms, if you find out, these are going for the storing or hiding of the information into the least significant bits of your data itself, and that data you may consider as if it is the carrier signal. So that carrier signal, and if any information is there. Of course, if the data or the file is your text containing carrier signal, then there is no need of going for the LSB, because anyhow if you are going to change the contents of your text itself, because if you go for the 1010 as the ASCII code for your text itself, and even if you go for the change of the one of the bit from any one of the position, then the text will go on changing. So that may be considered as if one criteria for your cryptography, or it is the combination of the steganography or the cryptography. Definitely I would like to comment on the cryptography and the steganography and the differences of those one in some different session itself, because it is of most importance requirement whenever we understand any of the technique. So obviously for whenever we go for the steganography, it is considered that it's a hide and seek game. So you must have played that particular hide and seek game in your childhood. So wherever you make yourself hidden in the particular room or the campus, whatever are there, so hiding and then seeking down, there is some overhead for this one. So you can say that it is one of the drawback, and some skill is required to hide the content and of course to get the content back. And that's why I can say that there is some overhead to have certain say operation over this one. So we can go for those operations one by one. So I can say that okay, in the ancient way there are certain mechanisms to go for this steganography, but whenever we go for the modern day, we are having certain carrier signals, and those carrier signals may be any of the signal or any of the media of your multimedia content. So you may say that it's an image, or it may be the video, or you can say that it's audio, or even it can be a text itself. And whatever are the images or the video, you can have certain extensions for the file itself. Of course, those files, whenever the extension is considered, some of the characteristics are there, and we are using those characteristics for the hiding purpose. Maybe your BMP file is there, the issue of the header is available or not available, the footer is available or not available. So depending on the characteristic of the extension of your file, okay, we can change the criteria of hiding of the information. And there are number of say ready-made tools are there where you can hide your information. So there are certain say applications where we can say that if any digital forensic detection is there. Of course, for the digital forensic detection, Stigmography is considered as one of the important tool, because when we say that some slack spaces are there or some alternative data streams are there with your computers, or whenever you are having certain backups, so whenever you need to find out certain information which is stored with this one for certain intention, maybe you can find out some applications in intrusion detection systems or intrusion detection prevention systems. Normally these are called as the IDPS. So in such cases you may find out there are great applications of this steganography, or some communication is there for the TCP IP as the one of the protocol. Then those headers may contain some of the information, and that information is always known to the sender and the receiver, and some of the identities, some of the key or some other information which should not get exposed to the common user, this can be hidden down into the header itself. So there are number of interesting applications, and we would like to go for those applications. So as if the overview is considered, I'll say that there is some video. I'll call this as the multimedia signal. There is no general mechanism to hide in any of the media. You need to have certain say separation of this one, and there are individual algorithm which may work over the audio, or rather which may work over the text, or which may work over the video, and hence with the images itself. So you are having some different algorithms, and those different algorithms may have some requirement, and ultimately having the individual work for this one, you may say that there are certain mergers, and those mergers will allow you to combine the multimedia data. So the point for the discussion here is that there is no any universal algorithm for any kind of the media. Depending on the media, what kind of the media you are using, you need to go for some different algorithms, and such study of the algorithm is very important. Now to the focus of your particular steganography, I would like to go for one major characteristic or major classification criteria, I'll say that it's an invisible steganography. So majority of the applications are going for the invisible steganography. That means whatever is the stegomark, that is the bit stream you want to hide, that can be inserted into your carrier signal. I'm using here the images because I believe that showing images, it is a very good option for understanding the concept. Conceptually, if we want to get any of the idea, then images are very good for the demonstration, or rather you can have any bit stream, or you can have any 1010 pattern, maybe in terms of your text or maybe in terms of your audio itself. So for the demonstration purpose for this session, I am using some images here. So you may say that this is one of the image. I purposely use the image where you can have the extensive, say, correct, some of these smooth images are there. Whenever I say that this is a smooth portion or the low frequency pattern, and wherever you can have some textured pattern. So ultimately there are certain adaptive categories for your steganography, that it depends on the what is the portion of your particular carrier signal in which you are hiding the stegomark. So that particular portion I'll cover say bit moment later. So I'll say that this is the carrier signal and some stegomark is to be embedded into this one, and definitely you are finding here the resultant or the combined image. That combined image, I would like to say that this carrier signal plus stegomark is equal to this combined image. So I can say that there is a challenge for any of the observer that okay, just try to find out the difference in between this or this. So definitely we people being some perceptual characteristic for us, or rather we are having certain limitation. So those limitations says that having certain threshold, finding certain threshold of your human visual system, if the stegomark is embedded below that threshold, then definitely that particular insertion is not viewable by the common observer. So we can say that this is the kind of your invisible steganography. And there are certain attempts that okay, some of the cryptographic keys, maybe the private key or the public key, can be combined with the steganography. So crypt stego, maybe the combined operation you can have here. So as I said, this is the carrier signal, this is the stegomark, and then you are having the composite or the combined image, and that is not giving any idea that something is hidden down itself. So this is the kind of your invisible steganography. In contrast to that, your invisible steganography, there are some visible steganography. So you can say that there is some carrier signal, you may use some keys, or these are optional for the embedding or the retrieval, and something is inserted into this one. So you may say that this is having some kind of your watermark. So whether the watermarks and the stegomarks, or the steganography and the watermarking, whether these two are the same mechanisms, okay, we'll have a talk over this one. Actually these are having some similar mechanisms, but rather it differs with certain applications. So that point we'll discuss in a while. So whenever I say that this is the carrier signal, some marks are there, and those marks say that these are some authorization marks. These marks claim that this particular image is belonging to, say, if it is the IBM, possibly for the IBM. So IBM is having some ownership for the image itself. So the major purpose of this particular visible steganography is the authorization. So as I said that we need to find out different applications, and according to those applications we may have here the usability of the particular steganography. So if I go for some reverse operation, that is if I want to remove this particular visible watermark, I would like to make a comment that whenever we are going for some invisible steganography, removing of your particular stegomark from this particular carrier signal or the composite signal is slightly simpler than removing this one, because after removing the particular watermark or the stegomark, one will be in the interest that whether you are interested in the particular inserted bit patterns or the carrier signal itself. So which is for your help purpose and which is for your application purpose, whether you want to have this as the end product or you will have this particular watermark or the stegomark as the end product. Depending on this one, you need to go for the choice of the application, or rather the choice of the algorithm. So whenever the data is hidden down in itself, I would like to make one comment, because if I find out some size of this one, or some if you go for the properties of your images, it will give you the say resolution of your image, and that resolution give you the x-axis or and the y-axis pixel, that is pixel to pixel, or the density of the pixels per unit area. So whenever the data is inserted into this one, that data, that is the changed data, is replaced from the original one. That means the size of the original image and the size of the Stigo image is the same. There is no increase in the size of the image. That is a very important, and that's why whenever you try to remove this one, obviously the original contents are lost. You are not able to get the original contents. So somewhere you can have some averaging or some smoothing operations are there, some filters you can use wherever you can retrieve back the original information. So I would like to make a comment that if you want to remove the Stigo mark from the visible steganography, then definitely it's a hard task, it's a complicated task than removing the Stigo mark from the invisible steganography. So just have a concentration over this one, or you may have certain discussion, further discussion over this part. So as I said, depending on this one, we need to have a choice of the algorithm. Now, I would like to give you one good analogy, or say in what way it will work. So I say that there are some logical compartments of the operations, and these are given with some dotted lines. So I say that this is the sender side and possibly this is the receiver side. So when the sender and the receivers are there, let some communication channel is there, and there is some threat level in the communication channel that there is some distortion may happen. So I say that there is a sender side, and with some needle, this is the indication of the key itself. So it is giving me some watermark as the one of the category. Right now I am just not bifurcating watermark and Stigo mark. Okay, we can use a similar fashion, and then possibly we can go into the further details so that we can change, or we can discuss about the watermark and the Stigo mark. So we are having some host signal, we are having some embedding, so as some reverse operation is there, compatible operation rather, not exactly always the reverse operation, that will go for the extraction. So whatever is your host signal, that host signal or whatever you will embed as a Stigo mark or the watermark will be retrieved back at the receiver side, and that too with the particular key what you are using. Maybe this can be combined with the private key or the public key, or the use of the key is optional. So whatever the coding or the embedding is there, you can say that that signal is always in the 1010 form, and that you are going to retrieve back as if it is at the 1010 form, and you need to check that okay, whatever you have embedded, you have retrieved the same, and if it is the same one, you can say that the estimation or the detection or the encoding, not encoding, it's a decoding is the correct procedure. So whenever the particular communication channel is there, now let me concentrate this particular part because this is very important. When we talk about the communication channel, we need to concentrate one thing, that whatever is the host signal you are using and whatever is the watermark you are using, there is no similarity in any of the spectral characteristic of both of the images. And if no similarity is there, that added signal is always treated as the noise by the communication channel. I'll tell you that as there is no relevance in the host signal and the whatever the Stigo mark or the watermark you are adding there, as the less relevance or the less compatibility or the less spectral relationship or the correlation is there, that means this particular watermark or the Stigo mark is considered as if it is the noise added into the particular signal itself, and definitely the channel tries to remove this particular noise. There are certain compressors or certain filters which are under operation in the communication channel. So I would like to say that there are certain distortions, and those distortions may be incidental or it may be intentional. So what kind of the incidental operations are there? Definitely, as I talked right now, that the noise removal may be one of the common operation by the communication channel. So right now for this particular operation we can say that it's a distortion because we don't want to remove this noise from the given content itself. So if any filter operation is there or if any compression is there, for example, if JPEG compression is there, for the JPEG compression it is using some DCT as the transform, discrete cosine transform, for the compression of this one, and most of the times DCT gives you lossy compression. So in such cases some of the data will get lost, and if that data is getting lost, then definitely you are not able to recover in a required manner. So I would like to say that these are the incidental distortions. But some of the other distortions are there. For example, if some opponents are there, those opponents try to hack or get or grab the information in the particular channel. So these are the specific mandatory or which are the intentional attacks, you may say that. So whenever that particular data is to be transferred over the communication channel, we expect that whatever are the incidental or even intentional attacks are there, my particular algorithm should sustain for those such attacks. That means I need to go for some development of robust algorithm, that robustness against the survival of particular incidental and intentional attacks. On the contrary, if I go for certain application, I talked about for the application which is the forensic analysis, that is the digital forensic analysis. So in a particular channel, if any attack is there, then definitely some mechanism should be there. That mechanism should help that okay, some attack has carried out. So in such cases, if any small change is there, if any small alteration is there, that alteration needs to be indicated. So in that case, I need to go for some fragile algorithms for the purpose, which go for some forensic analysis. So I have discussed two cross purposes right now. One thing on the other side, I'll say that it should be robust enough to sustain in the communication channel, and on the contrary, I am saying that it should be fragile enough to go for certain distortions or to understand those distortions and reflect those distortions, so that the analyzer or any forensic person is there, he may understand that okay, there is certain attack or some attempt was there. So how to cope up with those particular idea? So obviously there are certain say efforts carried out for the say Stigmography or even for the watermarking purpose, and if the research is considered at a glance, I would like to say that there are two major attempts. One is the communication theory based algorithms are there, or rather some study was there, and the other one is the information theory based is there. So what exactly is the communication theory based? That means the communication channel is considered as the prime work where algorithm is developed, and whatever are the attacks, possible attacks are there, some analysis is carried out with this particular communication channel, of course with certain constraint of the bandwidth and whatever the data you are using for this one. And if the particular analysis allows you to have certain detection, because whenever we go for the intrusion detection or the intrusion prevention is there, in many of the cases we understand that some of the attacks, even if we are able to understand up to the detection level, not for the provision of the removal of this particular attack, but we can say that okay, we are having certain success over that particular access or detection of this one. So in that case, you may have some attack machines. You must have heard about some of the attack machines which are having the name as the Steganography attack machine, or you may have some Certimark attack machines. Of course, these are some outcomes of the research communities which are doing or which are engaged in continuous operations or the development of the algorithms are there. And there is another criteria where you can say that there is some information theory based algorithms are there. Whatever algorithms are existing or are developed, these are analyzed wherever attacks are modeled down, and the researcher tries to find out certain say calculation of the parameters for the specific attack or for the specific algorithm, where those parameters ultimately will reach to some say peak performance, wherever some stability is observed at that side, you can say that these particular say parameters are getting fixed. So it's like a game approach, and that game approach will allow you to have certain modeling of your particular say circumstances or the test beds, and such information theory based algorithms are there which are developed. So such type of the classification we need to understand, and if any algorithm is to be referred, then we need to find it out whether it should go for some communication channel parameter as the major one or whatever is there, because which is of major importance, whether you are having some noisy channel or whether you are having a channel where the majority of the attacks are possible, or whether you are having a very clear channel where there is no threat of any of the communication. So in that case, finding out the scenario, definitely you need to find out the algorithm itself. So again, I have tried to go for the research efforts. Those research efforts, I'll say that, as I said that there are some robust algorithms, there are some fragile algorithms are there, or fragile marks are required. wherever you need to find out certain any minor change should get detected for the particular purpose. So there are some say integrity checksum efforts are there. I have given some of the attempts. These are not connected at all. I try to give you one axis which is just starting from the fragile to the robustness, or rather it will go for some visually distortions you can say, or some of the loss you may observe. And these are totally independent efforts. You may not have any connection for this one. So many of the algorithms, if you find out, that is the LSB methods are popular in the steganography. So least significant bit encodings are there, or you can say that there are some data hiding techniques. I would like to say that watermarking and the steganography, these are the categories of the data hiding. The major technique is your data hiding technique. So non-security related data hiding techniques are there, where the security is not the major concern if you consider. Or you may have some image checksums are there which are going for your integrity check, where these are necessarily going for your fragile marks and the provision of such type of the thing. But if you move for some frequency transform, before going to the frequency transform, I'll say that there are some special transform algorithms are there which necessarily work on the histograms or the intensity values or some pixel values are there, and such statistical methods are there. These are again working in an independent way, and there are certain visual watermarks are there. As I claimed that there is a loss of information because the watermark or the stegomark replaces the information of your original content. So some distortion obviously is observed here. Whenever I'll go for some frequency transform, obviously in the literature those transforms are popular. You may find out that there are some cosine transforms, say algorithms are available, but apart from the cosine transforms, some wavelet based transforms are popular, or these are giving good results for the particular steganographic algorithms. You may find out that there are some Hadamard transforms also, or there are some KL transforms also. But right now, as per my knowledge, say wavelet transforms are giving better results, and they are having wavelet transforms are having some different say resolution possibilities, and those resolutions we can use for the insertion of the elements. Okay, I would like to comment on this one a bit later. So I'll continue here that whatever are the techniques, I have given you one idea that okay, it can be classified as if it is the visible or invisible. The second definitely will try that whether it's a spatial domain effort or whether it's a say frequency domain or the transform domain effort is there. Transform domain, one of frequency domain is one of the category of your transform domain, rather I would like to say. Also there is some another say classification criteria where I can say that the algorithms may be public or the blind, or these may be the private or the non-blind. So what do I mean by public or the blind algorithms? If the public algorithms are there, if the steganographic algorithms are there where the sender and the receivers are there, and at the receiver side if the original signal is not required, then we can claim that these are the public, or rather these are the blind algorithms. And in a other way, if the original signal, that is the host signal, is required at the receiver side for the detection purpose, then it is definitely non-blind method, or this is the private method, or you are having some private key for the workability of the such applications. So in such cases you can say that if you are receiving some say stego signal at the receiver side and some original signal at the say sender side, and it is a pure spatial technique, then definitely you can have the difference of the both signals, maybe with the subtraction as the one of the operation, and you can get what exactly is the embedded there. So these are simple concerns or simple operations you may carry out over this one. I was talking about the domain specific techniques. As I said that some spatial domains are there and some transform domains are there. So in what way these differ? A slight idea I would like to go for this one. If spatial domains are there, in a major cursor, a single pixel or a neighborhood of this one pixel. Why I am talking about pixel? Because right now, as I said that I am working for the images itself. So stegomark is embedded directly modifying the pixel values. Some values, some characteristics are there. majority of the times pixel values are in terms of your pixel intensity values, but rather you can go for some other characteristics in some of say color platelets of there, or you can say that some alpha values are there, or you may say that hue or saturation is there. So accordingly you may change for your particular characteristic of the pixel itself in the spatial domain. It usually prefers for the spread spectrum approach. So that is another approach which is the added part for the spatial domain, because in the spread spectrum it considers for the neighborhood and nearby pixels together will allow you to have the hiding of the information. So rather than going for a specific location as the IJ location which is not concerning any neighborhood, or rather you can consider the neighborhood and the entire spectrum of your particular data. So obviously the spread spectrum approach in which the spectrum is considered, these are popular techniques in the spatial domain. In the transform domain, as I mentioned that, okay, transform domain I am not going for any time domain, I am just going for the frequency domain. So Stigomar can get embedded into some discrete cosine transform, discrete Fourier transform, or discrete wavelet transform, because these are the majority of the attempts are there. The attempts said these attempts are very different, because in discrete cosine transform I would like to mention one idea that if we divide the given image into some of the components, most of the times it is divided into 8 by 8 components. So its DC coefficient and AC coefficients are the characteristics of the specific block. And normally the DC coefficient is having the average of the values of the remaining coefficients in the given block. So if you just target that DC coefficient, then it's a very simple to work in the discrete cosine transform. Rather, if it is the discrete Fourier transform, we understand that in the Fourier transform the magnitude and the phase can be differentiated. So keeping the magnitude as it is, not changing any of the elements of the particular image itself, if we try to embed into the phase component, then it will give you some success in the discrete Fourier transform. In the discrete discrete wavelet transform, as I said that there is a multi-resolution aspect, and you are able to divide the given image into the low frequency and a high frequency part. And of course, it is very good idea to embed into the high frequency part for the given image itself. Why? I can have a discussion further. And that's why in such cases the discrete wavelet transforms are useful. So depending on, as I mentioned that, depending on the application, depending on the how much of the computation you can consume, you can go for having the choice of your transform itself. In a spatial domain techniques, there are certain simple idea. As I mentioned that histogram is one of the idea where you can have the gray level patterns, or say number of coefficients of having the same intensity, and wherever you can just check out that maximum occurrence of the specific intensity is observed, then you can go for having the choice of such gray patterns of the such coefficients where you can embed more. So LSD is one of the popular technology. The other one is the histogram modification, or you will go for some difference expansion where in a particular image itself, image is one of the carrier signal. If you are having certain gradual change in your texture, I commented on the low frequency and the high frequency. So if you are having the change over the frequencies, and wherever the change you observe, that means some edges of your particular patterns are there. Those edges are very good, wherever you can hide your information in a very nice way. So you are having some difference expansion, maybe having the combination of the 2 by 2, or maybe having the combination of the 4 by 4 are there, or you can use such boundary values are there, and those boundary values are allowing you to embed more than your smooth portions. So that is again the good idea for the research purpose. Whenever we concentrate for the LSB hiding, it is said that suppose I have 8-bit image with me, and what are the contents of the 8-bit? Obviously the most significant bit is having the maximum content of the information. The information I have given here, the Lena image, which is the very popular image and which is using widely in any of the algorithm for having the test or the comparison of the tests are there. So maximum information of your content is there always in the most significant bit, and if you go for the number of bits, which is the LSB, if you consider, the least information is stored in the least significant bit, and that's why majority of the attempts are having the choice of the least significant bit where the new information or the Stigo information can be embedded into this one. even if it is embedded into the least significant bit, a single bit or the 2 bit or the 3 bit. If you go for having the say engaging more bits into the embedding of the new information, then definitely the contents will be visible, or rather the original information, the carrier signal is getting distorted. So in such a way, suppose this is the carrier signal and this is the stigmomark, what you want to hide into this image. Many of the time, whatever is the size of your carrier signal may be the same size of your embedding you are using, or it may be having some small size, and that small size may be embedded into nearby blocks itself. Right now I have given this as the grayscale image and a signal which you want to embed as the grayscale again, but many of the time it is having a choice that the signal where you want to embed is the grayscale or the color image, and what you want to embed is the black and white, because it is always in the 1010 form. But it doesn't make any difference, because you are having your information in the 1010 form, and which information you want to hide. If it is the gray information, obviously less information will be stored into the carrier signal itself. Now I will comment about the capacity of the carrier signal. So definitely that capacity is having one of the concern of this particular category of your image which you want to embed, whether this is the color image, whether it is the say grayscale image, or whether this is the black and white image, or how many planes of the colors are there for the embedding, and how many color planes you are using of this carrier signal for the embedding purpose. So all those combinations we may have a good option for the thing. So whenever I'll say that in the given Lena image, if a single LSB is used, one bit is used for the embedding, you may have such type of the visual. If 2 bits, 2 LSBs are used, then such type of the visual is there. If for the naked eyes, I can comment that okay, there is no major difference in this image or this image. But if you obviously compare this a single bit image embedding into the 6-bit embedding, then you can find out that there are certain traces of the information which you have hidden into the carrier signal itself. So somewhere you can have the balance, or you can say that you can get the idea that how the information is embedded into the particular image itself, so that the distortion occurred, and how much distortion is affordable to you, it's up to you, and so that you can embed, or these many bits can be used. For example, I may have analysis, or I may have certain metric for the distortion. For example, if the image, the original image is having some SNR value or the peak SNR value, PSNR value, normally it is measured in the decibels. So original image and a changed image, if you want to go for this one, you can find out the comparison with the PSNR, which is one of the popular metric for this one, and some allowable distortion you can go for. For example, if the PSNR is 40 dB decibels, then it is said that okay, that 40 is one of the allowable threshold, and if you are going below 40, then it is not good. So when I say that okay, good attempt is there for the Stigmography for the hiding information, 60 dB is the good one, 80 dB is the quite good, because this is normally occurs with the color carrier signals itself. So accordingly we can keep our say requirement, and according to those requirements we can put up, or we can have the combination of such things. So such theory can be studied in a very well manner. Of course, whenever we are having reconstruction, this is going for the single bit image, that is the say black and white image, and in contrast to that, if we are having 6-bit image for the obviously, so how you are going to have the extraction for this one, how the retrieved stegomark is having the distortion which can be compared with the original stegomark, and how much of the loss of the information for the retrieved stegomark you are allowing, that is totally we can have certain statistics for the consideration of the thing. There is another idea that whenever we are going for the LSB hiding, instead of just considering a single image, which is the entire image, we can have, or we can go for certain patches of the image. Of course, right now those patches are given in the spatial form, but if we are going for some transform, wherever the patches can be differentiated according to the low frequency or the high frequency, and which is a good application given by the discrete wavelength transform. So you can use one patch wherever you can hide something, where the other patch is there where you can go for the hiding of the different thing. Likewise, you can say you can embed as per of your choice. There is another idea that you can say that there is some mosaic is there. I'll just go for the figure first. The figure says that okay, this is one of the figure which is given in the mosaic form. Wherever you can find out that particular image of the dog is formed with very small images, and the individual images are again of the dogs. And some of the images if are selected, then the selection of the images is given here, and say opponent or the other person who is not knowing the fact may not understand what exactly is the criteria for the choice and what exactly is the output of that particular image. But it is said that whatever is the image mosaic you are having, say this mosaic you are saying in a way, these particular images are having certain numbers with their positions. So I would like to say that the sender and the receiver share the same image database, and the position of the particular image in a database is having certain sense, and that sense, or I would like to say that a single image can be considered as the one of the tile of that particular database or that mosaic itself, and it will correspond to some integer may be location wise, and that may have certain following of some pattern for the picking of the particular images. Not necessary that always it is going from the upper left to the lower right with the left to the right scan. Normally it is of the your raster scan, but there are different patterns, and that pattern itself is one of the key. I think I have discussed that patterning concept in one of the sessions, in one of the videos itself. So that pattern can be utilized for having the nomenclature of the image and having the say positional integer association of that particular value. And whenever your algorithm is there, some choice of your different tiles are there according to the requirement. So some secret message may get associated with those integer values with this particular say position, and those particular tiles can be grabbed at the receiver side, which gives you some message extraction. And that message extraction, I would like to say that this particular combination is giving you some message, and what exactly is the message may be having some integer associated with this one, and that integer value may form certain message itself. So that is the idea of having say some indication for referencing of your particular elements, and that is nothing but the steganography. There is another idea that suppose I have certain say message here. Let the messages are given with the F here, F1 and F2 are the two patches what you are saying here, and say there is some key which you can have some operation, some complicated operations you may define, or rather you may have certain weightage which can impose or which can map over this one, where the according to the weight matrix you can just have the calculation or some function definition. Like you might have heard about the knapsack problem or the knapsack cryptography, where the weightages for the individual say sacks are given or individual beans are given. So such weightages itself may be another key. And for example, if the value of this particular with the key is considered, say upper left is if it is combined with the upper left of your key with some certain say XOR function, so 0 with 1 which gives you the 1 as the result, or 1 XOR with the 1 which gives you as the 0. So likewise any of the combination can be made, or some of the function can be inward, and of course that function can be used with some say round operation or some say clockwise operation, and according to you can have the contents of the resultant one, and of course that can have a certain algorithm, and that algorithm needs to understood or needs to be declared with say some source and the destination, that is the sender and the receiver. There is another idea that suppose I have some object. Right now you can find out some black patches there, but suppose I have some original information with some object say contour is there, some background is there. Right now that background is just having some checkerboard. If that checkerboard is say combined with the other one, where you can say that the ultimate 1010s are there, and accordingly if some fusion is made down, that with the particular contour of your object you may find out that there are certain changes or some outlines are observed, and with this particular outline obviously you are able to understand or recognize the pattern. There may be certain say AI algorithms which can be combined with this particular idea, wherever the recognition of the pattern may be there. So some fusion techniques may be there. So this is one of the idea I would like to share with you people, where you can have your own idea to go for the further algorithms. I talked about for the adaptive steganography, wherever I have taken one image only. Out of this image, I have chosen 3 different regions. Say first region is there, the second region is there, and the third region is there. And I want to work with this particular region. Normally it is called as the region of interest, where you want to work. So in the region of interest of the first, you can say that it is not having a great change or the major content of your particular image itself. So I would like to say that this is the smooth part, rather this is the textured part where you are having some information content over this one. The third block is containing higher image or rather higher texture, because you can say that there are alternative bands are there. So to the image content, obviously the capacity of hiding the information go on changing. So it adaptively changes the regions where you can embed, or it adaptively determines what is the capacity of the individual patterns or individual say blocks what you are choosing for the. So that particular process always go for having some adaptive steganography, where some portion you may mask and the remaining portion you may utilize. So there are certain mechanisms or you can have certain combinations which will allow you to have the lower detection by the opponent itself. So some algorithms are there and it's a very fun to work with such algorithms. As I discussed that okay, there is some DCT based algorithm. So if I just try to compare with the spatial domain and the DCT domain, most of the times DCT is using 8 by 8 column, and as I said that okay, if you are aligning the two, that is a row by column in your spatial domain into a single dimension array for the recommendation, so you may hide something over this one, some equational idea is there. I am not say going in detail for the calculation, but I would like to just mention here that whenever you insert into any of the transform domain, then that definitely depends on the content of your image, and that content, if you want to go for that content is measured in terms of the variance of the particular information. And that variance, if we try to calculate with some of the measures, maybe standard deviation of your content is there, because how I can differentiate the high content image and the low content image. So obviously I need to have some statistical calculations for this one. Say standard deviation is there, variance is there, or some other are there, where you can have the calculation and you can go for the workability. If any algorithm is there, when I choose for some carrier signal and the signal that is to be embedded, definitely I need to have the relation of the mutual information, where what you want to hide and where you want to hide. Say if X is the carrier and Y is to be embedded into this one, then mutual information of these two is very important idea if you want to go to enter into any of the statistics, and that statistics will help you to go for the say spread spectrum category of information storages. So if you try to find out some entropy and the calculation and the matching of the entropy of this one, then definitely you are able to estimate the bits and the entropy of the bits, how much you are going to embed into this one. So this is another area where you can have your concentration and where you can go for having the further studies for your particular steganographic algorithm. Very less information is there with the literature for such type of the algorithms and the key idea behind such algorithms, but still it is very important. I would like to comment upon that I discussed about that is the say low frequency information and the high frequency information, and I'll say that whatever is the information you are hiding into this one, that is the stego image, I may say that it is the noise, because it is the unwanted signal or it is the extra signal, or rather it is not matching to the signal of your carrier signal. So I'll say that it's a noise, and if that noise is visible or not visible, you may say that some functions are there, and those functions, a visibility function for the specific location of ij into a particular image is say inversely proportional to your say variance of the image itself. So variance at that specific location you may find out, and you may have certain say equational relation for this one. So if any stego function is to be utilized, then it is having some relation to the local properties of that image. So if I say that if any delta change, if any minor change, or if some distortion is to be made into the location, that distortion, I'll say that how much is the maximum allowable distortion that allows you that how much you can embed in a maximum way at that particular location. So I say that if it is somewhat the textured parameter, I'll have certain constants, or this is the ready-made signal, but that signal or that equation you may change according to the application, and that is giving you some algorithm background. So if it is the say allowable transform coefficient distortions in a textured, which is the S0, and it is the flat or some low frequency region is there, which is the S1. So you may have those constants, and those constants will allow you maximum allowable distortion at the specific location. So I'll have certain say application and some image characteristics which are getting changed because of this. I may have some exercise over this one. So whenever we talked about for the image steganography, similarly you may have some audio steganography. I'm just giving you one hint for the audio steganography. We are not discussing in detail. So you may have a choice of the changing the least significant bit of your particular audio signal, or you may change the phase for your particular signal, or again you can use some speed spectrum, so that whatever distortion you are making, that is not audible to the normal ear system, you may say. Or you may say some you can insert some tone, or you can work with the echo of your particular audio signal, and you can go for. I would like to comment on the very important characteristic that whenever we are going for some information theoretic aspect, and if we are talking about the security concerns for the steganographic algorithm, so I would like to say that steganographic algorithm, actually it is not meant for the confidentiality or secrecy for this one, but still how much it is say giving you the particular result. I say that there is no unit to measure the security. There is no idea whether my algorithm is secured or not secured. You need to have some relative calculation for this one. Like whenever we comment about say distance is there, distance is always in the meters or the kilometers. Or if I say that some time is to be measured, it is in the seconds or the days or the months are there. But if any security is to be measured, there is no any standard unit for this one. So we have to represent this particular security aspect or the concern in some relativity. So I say that there is some sigma secure concept where the relative entropy or the energy between the cover image, cover signal or carrier signal and the information what you want to hide, that is the stigomar. If you are going for the probability distribution functions for this one, and if these are having some say matching spectrum from one to other, then definitely the difference is very small. So if I say that if the difference is to be calculated for the carrier signal and the stigo signal, then it is in terms of having some calculation, you can find it out here. And if it is less than with certain value as the sigma, obviously that sigma should be equal to 0 for the perfectly secure system. We are not able to go for any perfect secure system because this is the ideal situation. We need to go for some practical situation wherever you demand that the value of sigma should be as less as possible. That means your carrier signal and your stigo signal should have some matching in terms of your spectrums. So if you are saying that if it is having some less than value with some value sigma, then it is the sigma secure. What is the value you are choosing? So that is one of the metric you may use, and that is actually one of the added information which is not commonly available anywhere. I would like to say that there is another idea for measuring the security, because whenever we secure, suppose I have certain say probability and if some false alarms are there. What is the false alarm for the detection? I say that if the message is detected, that means whenever we consider that whether the message is hidden or not. Message is not hidden, but we have detected it, then obviously we will say that it's a false alarm. That is, we have detected in a false way. So we are having certain probability for this one, and actual detected message is there. That is, message is there and we have detected. That is, it is the true concept that we have detected. Suppose these two terms are given in a way, and if the idea comes that the false detection and actual detection, if the probability is matching, I can give you in a particular graphical way that if the probability of the detection and probability of the false alarms are there, and if it is the particular say guesses are there, I am saying that guesses, that if the line is there or particular attempts are there, that it may be this one, or it is having equal probability for this one. So it is going for the 45-degree line for the particular equality. if such particular equality goes for the 45 degree as the line, then it's a pure chance for the guessing. It is not giving either having the false alarm or it is the actual detection, and it gives you the pure random guess, which is the 45 degree line for this one. Or otherwise you may say that the steganographic algorithm is eta secure. Eta is another measure for this one. I expect that the value of the eta lies in certain boundaries, that if I go for the absolute difference of the false alarms and the actual detection, and if it is less than with certain value, that value is the eta, then I will say that it's a eta secure. So obviously, logically, by default, the ideal condition is that eta should be 0, but and that is giving you the perfect security consideration for the detector level. But it is very difficult to go for the eta secure or the sigma secure, which is equality as the 0. But we need to reach to those values, and if any attempt is there, that attempt should be there that whether the value you are using the sigma or the value of the eta, both should be as small as possible. Up to that you can make your attempt. Likewise, if it is the game approach or if the information theoretic modeling is there, you can have the solution in that way, wherever you can reach to that particular maturity level, where the maturity level can be observed at the value 0, and then you can test your particular algorithm. So that is one of the idea what I have given to you. And whenever we want to work with any of the algorithm, maybe cryptographic algorithm, maybe steganographic algorithm, so whatever cover object or the carrier signal you are using, so what kind of the carrier signal I have to use so that with maximum capacity I can embed is the great thought process, rather than just studying of the say LSB steganography, which are very popular and the ready-made algorithms are available. So what kind of the images, what kind of the spectrums, what kind of the entropies, what kind of these matchings of the stego to the carrier are good for the cover object is the another area where we can make certain research. And there is another idea that whatever are the carrier signals you are using, many of the algorithms you may find that the image characteristic itself can be taken down, and that can be considered as the stegomer and can be hidden down into the self image. In what way it can be gone? Okay, because that is going for the having the say some signature of the carrier image itself, the signature of the bit patterns what you are sending from the sender to the receiver. The signature can be carried out with the image characteristic, and that is having excellent idea wherever we can go for certain research. So I would like to say that okay, there are number of criteria where we can concentrate for the steganographic algorithm, and this is just one of the hint what I have given to you to have the study in the steganographic attempts, and definitely it together we can go for some joint research or some joint idea wherever the idea can be extended for the better utility values of your steganographic algorithm. By this time, okay, I'll pause here. I'll continue with this particular concept in some further video itself, because as we have studied as the steganography, there should be some concept which is hand-in-hand concept, which is called as the steganalysis concept. Whether you want to estimate the hidden information, maybe for the betterment of the usage, maybe for the forensic analysis, that is the digital forensic analysis. So by this time, I'll just pause here. Thank you.